Today, I wanted to prove one of the most famous theorems in mathematics, the Pythagorean Theorem. What this theorem states is that for any right triangle, the square on the side opposite of the right angle is equal to the squares on the other two sides. When I say that those are equal, what I'm meaning in this video is that their areas are equal. So the area of this red square is equal to the area of this blue square plus the area of this yellow square. In this video, the arguments I'm going to be using will all be coming from Euclid's Elements, Book 1. Whenever I use any of these arguments, I'll post them to the screen. And with that out of the way, let's get to the proof. What we want to do first is we want to actually assume we have a right triangle, because that's our starting point. So I've gone ahead and named the corner points A, B, and C. Name doesn't matter, so use whatever you'd like. And with that, next we draw the squares that are on the sides. Again, corner points are named, picked from the alphabet. I like to name these something different because it helps put in your mind that this is our objective. And now that we have these squares drawn, we have to take a few more steps to start proving that these two squares are equal. But the way we're going to do that, the outline, is we're going to prove this blue square is equal to this blue rectangle, and that this yellow square is equal to this yellow rectangle. And then it's pretty easy to see that this red square is equal to this blue rectangle and this yellow rectangle. But to do that, the first thing we have to do is we have to take a line that starts at A, draw a line that starts at A, and draw it parallel to the sides of this red square. You draw it parallel to either one side and it'll automatically be parallel to the other. So I've gone ahead and done that already to save time. And that's this line right here. I'm going to name the point where it intersects the triangle. I'm going to call that L. And the point here where it intersects the other side of the square, I'm going to call that K. So now we have our points L and K, and we want to show that these are equal. So the first step that I'm going to do is I'm going to show that this blue square is equal to this blue rectangle. To do that, first I need to draw two different triangles rather. And to do that, I'm going to take a line that starts at A and extends to Y. And when I do that, I'm going to make this triangle ABY. And this is the line that you would draw to do that. Also, I want to draw another triangle that has a point starting at C and draw a line all the way to B. And that will give us this triangle. And we want to show that these two triangles are equal. In order to do that, we're going to use the side angle side theorem. So, what two sides are equal? Well, here we have this side BD and this side BA. We know that these two sides are equal because they're sides of the same square. And the definition of a square tells us that all the sides are equal. So that's not too bad. Similarly, we also do the same thing to say that side BY of this triangle is equal to side BC of this triangle. So now I have two triangles that have two sides in common. Now we have to be a little bit more clever and show that the angle in between is also equal. To do this, first we note that this angle, ABD, is a right angle. So that's right. Similarly, angle CBY is a right angle because they're on a square. So we have two right angles, and we know that all right angles are equal. Now we have to make a kind of obvious but maybe not intuitive assumption that ABC is equal to itself. So then that gives us this angle here in between. And what that does is now we have these two triangles that have this side equal, and the angle in between them equal. So since all those things are equal, by side angle side, we know that these two triangles are equal in every way. Specifically that their area is equal. And since these triangles have equal area, we can actually use them to show that the area of the square and the area of the rectangle that we want are equal. Because this triangle has the same base as this square. And if you look carefully, you can see that they also have the same height. We could treat this as the height of the triangle. And now the other side, we have that here's the base of this square. And again, this one's harder to see. But this triangle will have the same base as this rectangle. And they'll also have the same height because this line is parallel. Euclid calls these lying in the same parallels. So that's kind of my argument for that. But now I'm going to use the fact that the area of a square is equal to base times height, while the area of a triangle is equal to 1/2 base times height. So with that, we have the area of this square is equal to twice the area of this triangle because they have the same base and the same height. But the area of this triangle we said was equal to the area of this triangle, since they're the same triangle. But then this triangle has the same base and the same height as this rectangle. So that means the area of this triangle is 1/2 the area of this rectangle. So putting all those equal signs together, we have that the area of this blue square is equal to the area of this blue rectangle. We're going to do the same exact idea to prove that this yellow square is going to be equal to this yellow rectangle that we have. But in order to do that, we're going to do the same triangle. So if you feel comfortable with the proof so far, think you can do it the same way, just over here. Feel free to skip ahead. If not, I'm going to go ahead and prove that now. So to do this, we have to go ahead and draw two more triangles. These triangles are going to start from here, point B, and draw a line to point G. And that will give you this triangle, BCG. And then we do the same idea. We draw a point that starts at A and goes to Z. And that will give us this triangle, ACZ. And we're going to use the same tactics to prove that these two triangles are equal. CZ is definitely equal to CB because their sides are the same square. And AC is equal to CG. So those two sides are equal. And then we employ the same tactic where, since this is part of a square, this is a right angle here. Angle ZCA is right. And similarly, angle ACG is a right angle. And then the angle in between them, ACB, also has to be equal because it's the same angle as itself. Angle ACB equals ACB by identity. So again, we have the same story where it's two triangles that have two sides in common and the area between them in common. So by side angle side, they're actually the same triangle in every way, which means that their areas are equal. And we are going to make use of this fact so that we can prove that our rectangles are equal. So I'm going to put this back here, going to put this back here, and then again, similar argument. This triangle has the exact same base as this square, this rectangle, sorry, the exact same base, and we see by this parallel they have the same height. And again, this yellow square has the same base as this pink triangle and has the same height. So this square has twice the area of this triangle, which has the same area as this pink triangle, which has half of the area of what's left here, this rectangle. So what that proves is it proves that the area of this yellow square is equal to the area of this yellow rectangle. And now we're almost done, and it's pretty easy to see where the proof goes from here. So what we have is, we have that this blue square has the same area as this blue rectangle. And we know that this yellow square has the same area as this yellow rectangle. But we also can see pretty clearly that this red square is just made up of this blue rectangle plus this yellow rectangle. So what that tells us is this blue square plus this yellow square, the area on these, is equal to this red square. And that's what we were trying to prove.